can we know if functions are one-to-one function? So normally, and we want to do this using algebra, right? And so in the next video, I'm going to look at the horizontal line test. But in this one, I'm just looking at how do you use algebra to prove when functions are actually. So this is the premise on which we're going to embark on. We can use f of a and show that f of a is going to equal to f of b, all right? So basically what we're going to do, we're going to take two variables. We're going to take variable a and variable b, and we are going to substitute that in any one of these functions, and we're going to equate the idea, and we're going to work it out. And as long as we work it out, and we, at the end, we're able to see that a is equal to b, go. All right, let us go. All right, so let us start off with one of these. So let's say we're starting off with this one. So it says y is equal to, or you could say f of x if you want, right? So let us say we have where f of x is equal to 1 over x plus 2. So as we said, what we're going to do, we're going to take this function and we're going to show that f of a is equal to f of b. Right? So let's go. If this is so, then it is one-on-one. It is a one-to-one function. So let's go. So in this case, 1 over, so I'm going to substitute a here, 1 over a plus 2 should equal to 1 over b plus 2. So as you could see, I have substituted a and b where x is, and we're going to equate the idea. I'm going to do cross multiplication. So I'm going to take this, multiply by that, and then back to that. So in this case, 1 times b plus 2 will be b plus 2. So if you want to look at it like this, to say 1 times b plus 2 on the left, 1 times a plus 2. All right. So at this time, 1 times anything remains the same. So I'll have b plus 2, which is equal to a plus 2. At this time, I'm solving, so I could subtract 2 from both sides, and then I'm left with a is equal to b. So then this, by symmetry, I could say a is equal to b, right? B is equal to a is equal to b. So as you could see, we end up getting this, that a is equal to b. So as long as we substitute a or b, a and b in the function, equate them, and then try to break it down or solve, and we end up with a equal to b. This means that this function, f of x, is equal to 1 over x plus 2. It is a one-to-one function. So that's what we're suggesting, that we're able to do that. As long as that is happening, the function is a one-to-one. All right, let's go. Let's go for the next one. So let us say we're looking at, say, this one where f of x is equal to x squared. So we want to know if this is a one-to-one function. So if f of x is equal to x squared, then f of a must equal to f of b. Let's substitute. So this is going to mean that I'm going to substitute. So it means that a squared, because I'm substituting a for x, is going to equal to b squared, because I'm substituting b for x. All right. So at this time, I'm going to have to take the square root of both sides. So a is going to equal to plus or minus b. So as you could see, a is not necessarily equal to b here. A is equal to a positive b, as well as a is equal to a minus b. And this is where the problem is. This is suggesting that for some of the time, a is going to equal to minus b as well. And if that's the case, it's not one-to-one. Because if it is one-to-one, a must be equal to b all the time. So the fact that there's a possibility that we have other values than like a negative b here, as you could see, then it means that this is not 1 to 1, right? Not 1 to 1, because we have this coming in. A must equal to B, all right? So that function is not 1 to 1. Let's go for another one. All right, so let's go for f of x is equal to, say, 4x plus 1. All right, so if f of x is equal to 4x plus 1, remember, we're looking at f of a must equal to f of b. So in this case, we're suggesting that 4a plus 1 is equal to 4b plus 1. So let's solve this. So at this moment, I'm going to subtract 1 from both sides, as you can see. So when I do that, 4a is equal to 4b. And if I divide both sides by 4, then a is equal to b. This means that this function is 1, 2, to 1. So we have a 1-to-1 function right there. Let's take a look at another function, the last one, and then we're done. All right, so for this last one here, all right, so for this last one here, what I'm looking at is the fact that f of x is equal to x squared. But there's a condition here. The condition says that where x is greater than or equal to 0. So the premise on which we're going to embark is that f of a must equal to f of b. So if f of a must equal to f of b, then let us substitute a and b here. So this means a squared is equal to b squared. Taking the square root of both, plus or minus. So a is going to equal to plus or minus b. Now, what that means is that a is equal to b, as well as a is equal to negative b. But the condition here that is going to say this is that there was a condition given. The condition says that a must be greater than or equal to 0. And if the value is greater than or equal to 0, that means we're taking only positive in this case. So this is saying only positive values that we're working with, which means that this one will not be a part of the values that will be selected. So in this case, it is going to be a 1-to-1 function if x is greater than or equal to 0. So in this case, this would have suggested that, yes, we do have a 1-to-1 where the function is greater than, x is greater than or equal to 0. Look out for the next video here on pre-calculus, as we will be looking at the horizontal line test. How does the horizontal line test is going to help us out to determine one-on-one function. Thank you for watching Danny Mott's content. See you next time.